Now here, if f of t is equal to this integral over the circle C, where circle C is x cube plus y square equal to 4, we can also take this as mod of z to be equal to 2. Then we need to find the values of f3, f dash 1 minus iota and f double dash 1 minus iota. We need to find all these values, right? Okay. So this is the function given to us, and this is the circle mod z equal to 2. We need to find first f of 3, right? Now as f of t is equal to this, right? So just put t equal to 3 over here. So we get f of 3 to be equal to the integral 3z square plus 7z plus 1 divided by z minus 3 dz, right? Now we need to find the singular points. What are the singular points? The points where the function is not defined, right? That is the point where this denominator is equal to 0. So z minus 3 equal to 0 gives z equal to 3. Now we need to check whether this point lies inside this circle or not. No, this point is lying outside the circle, right? So whenever the point lies outside the circle, and that point we have got by putting this denominator to be equal to 0, right? Then what becomes our phi of z? Phi of z will be this complete numerator along with this denominator, right? This is your phi z. Please remember, for the points which are lying outside the circle, and that point we have got by putting this denominator to be equal to 0, then we have to take our phi z to be the complete numerator and this denominator, the complete fraction. If in case the circle is mod z equal to 4, then z equal to 3 lies inside this circle. Then in this case, we take our phi z to be equal to the numerator only. That means we will not include z minus 3 in the denominator, right? So we only include the denominator with the numerator for those factors for which we are getting the points which are lying outside the circle. So here our phi z is equal to the complete integrand. So phi of z is equal to 3z square plus 7z plus 1 divided by z minus 3. And this is analytic everywhere inside the circle and also on the circle, mod z equal to 2, right? So therefore, by Cauchy's integral theorem, the integral over C for this integrand is equal to 0 as z equal to 3 lies outside the circle. And this function is analytic inside and on the circle. So for this, by Cauchy's integral theorem, we say that this complete integral is 0. And this is nothing but your f of 3, right? So therefore, f of 3 is equal to 0, right? Let's move on to the second part. We need to find f dash 1 minus iota. Now f of t given to us is the integral with the integrand 3z square plus 7z plus 1 divided by z minus t dz. This time we are having the point t to be equal to 1 minus iota. Let's check whether this point lies inside this circle or not. The circle mod z equal to 2. 1 minus iota means the real part is 1 and the imaginary part is negative 1. So the point lies over here. This is the point t equal to 1 minus iota. Yes, this point is lying inside the circle, right? Because this point lies inside the circle, we have to consider our function phi z to be the numerator only, right? We don't have to include the denominator. Because for this denominator, when putting z minus t equal to 0, here the point t is 1 minus iota. So z is 1 minus iota and this point is lying inside this circle, right? So for this we take our phi z to be 3z square plus 7z plus 1. And this function is analytic everywhere inside this circle, right? So let's write this as phi of z is analytic everywhere inside and on the circle mod z equal to 2 and z equal to 1 minus iota lies inside the circle mod z equal to 2. This is the notation for the circle. So therefore, by Cauchy's integral formula, what is the Cauchy's integral formula? It is, yes, phi of t equal to 1 divided by 2 pi iota, the integral over c, phi z divided by z minus t, dz. Here t is equal to 1 minus iota, right? So taking this 2 pi iota on the other side, we get 2 pi iota phi of t equal to the integral phi z divided by z minus t dz. Instead of phi z, can I write 3z square plus 7z plus 1? So this is 2 pi iota phi of t equal to the integral over c 3z square plus 7z plus 1 divided by z minus t dz. That is 2 pi iota phi of t equal to, this is your ft, right? So this f of t is equal to 2 pi iota phi t, right? So that is equal to 2 pi iota. Okay, what is phi of t? We have taken this to be 3z square plus 7z plus 1. So phi of t becomes 3t square plus 7t plus 1. For phi z to be equal to 3z square plus 7z plus 1. This is your f of t. Please remember, this result is for the point which are lying inside the circle. For the point t lying inside the circle. Mod z equal to 2, right? So both the remaining parts can be done by this result. So let's first derivate ft with respect to t. So the right hand side becomes 2 pi iota into 6t plus 7. Just derivate this with respect to t. So this is 2 pi iota into 6t plus 7. So this is equal to 2 pi iota. Just put the value of t as 1 minus iota now. So this is 6 into 1 minus iota plus 7. So this is equal to 2 pi iota into 6 minus 6 iota plus 7. So that is 2 pi iota into 6 plus 7 is 13 minus 6 iota. Or we can also write this as 2 pi into 6 plus 13 iota. So this is your second part. And to get the third part, that is f double derivative at 1 minus iota. So for this, we need to differentiate this with respect to t. So differentiating star with respect to t, we get f double dash t equal to, from the left hand side we get 2 pi iota into 6. So this is 2 pi iota into 6. To get f double dash 1 minus iota, I am replacing this t with 1 minus iota and there is no t on the right hand side. So straight away you just solve this. This is 12 pi iota. So this is the value for the third part. That is 12 pi iota. Right? So we have got f3 to be 0 and f dash 1 minus iota to be 2 pi into 6 plus 13 iota and this value to be 12 pi iota. So this is how we solve these kind of examples. Okay, thank you. Stay blessed.